Okay, well, we were looking at 11.1. See, you remember that?
Yes.
Okay, this chapter is about rational expressions, so it's about fractions. And in this lesson, we're just talking about how to simplify them. We have to be able to simplify them before we can add, subtract, multiply, divide, and solve equations with them. So, it is all about trying to factor and cancel any like factors. So as you look at the numerator here, 2x minus 8. How can I factor 2x minus 8?
2.
2 and 8 can both divide by 2. So we can say that the top has a GCF, which should always be your first question is there a GCF? So we're going to put a 2 out front. What's 2x? And when you divide out 2? 1x minus, what's 8 when you divide out 2? 4. So are we okay with the numerator? Factor out the 2, it becomes 2 times x minus 4.
Yes.
Okay, denominator. Is there a GCF in the denominator?
No.
No, there's not. Okay. X squared minus 2x minus 8. How do we factor that?
Because you can do 2 without the x squared. You can't do x because of the b.
Right? So no GCF. What kind of form do we factor something that's like x squared plus bx plus c? What kind of form do we factor that into?
I can't remember.
Okay. Since it's just a 1x squared, this is an easy one. We're just going to go 2 parentheses. What do you know about x squared? It breaks into x and x at the beginning of each parenthesis, right?
Oh gosh, I can't remember the name of what this is, but I know.
Well, except is there an a value? Is there a number in front of x squared? No. So we don't even have to talk product of AC. We can just talk product and sum.
Yeah.
So we need a product of what?
8.
Specifically,
Negative.
-8. So we need two numbers that multiply to be -8. And give me a sum of what?
-2.
That middle term of -2.
Sorry, guys, I'm confused. Like that's 0 with a line through it. That's a cube. Sorry. That's what
But you can use.
Are you talking about the P for product?
Yeah, I thought that was a cube.
No, P for product. Okay, so what multiplies to be 8?
2 and -4.
Okay, so 1 times 8, 2 times 4. It's got to be the 2 and 4 in this case. If two numbers multiply to be a -8, we have to use a positive and a negative. If they add to be a -2, larger number is negative, smaller number is positive. So -4 and +2. Now, what we hope happens when we factor is that there's like factors that can cancel. Do you see like factors that can cancel?
2.
What'd you say?
2.
I don't see 2 2s.
No.
I see a 2 and I see an x plus 2.
Okay, x.
I don't see any plain x's.
I was not listening very close.
There's an x -4.
Are there 2 matching x minus 4s?
Yes.
Yeah, they have to be, the whole factor, remember, has to be matching. You can't just cancel. I agree. I mean, I was being smart. Like, there is a 2 and a 2, but this 2 in the denominator is connected. It's x plus 2. And you can't cancel part of something that's being added or subtracted. You have to cancel the whole factor. So if there was another x plus 2, we could cancel another x plus 2. If there was another plain 2, just plain old 2 by itself, we could cancel that. What we can cancel, factor of x minus 4, cancels with another factor of x minus 4. What remains after we cancel those x minus 4s out?
2 over x plus
2.
Yep.
And that's our answer.
And that's your answer. You cannot cancel those 2's because that denominator is x plus 2. It's not just 2.
So I sort of agree.
Now, remember, we have to simplify each expression. Okay, done, check, just did that. 2 over x plus 2. And we have to state any excluded values. Excluded values are pieces that will make the denominator equal 0. Now, what is our denominator?
X squared minus 2x minus 8.
Okay, so let me start with that for a moment. Out of habit, we go back to the original denominator, right? So x squared minus 2x minus 8 equals 0. Now, here's the deal. In order to solve that, we have to go back and factor that. So is there a different version we could have used here instead of x squared minus 2x plus minus 8?
X minus 4. X plus 2.
Yeah. Go back, don't look at what canceled, but go back to what did that factor into? That factored into x plus 2 times x minus 4 equal to 0. I would always recommend you use the factored version and set it equal to 0. Because then, I'm reviewing this with my Algebra 2 kids right now, if 2 pieces multiply to equal 0, you can set them each equal to 0. So we could say x plus 2 equals 0, and we can say x minus 4 equals 0. If it's x plus 2, I'm going to
Add to both sides.
mean subtract 2 to both sides.
Yeah.
So I'm going to subtract 2. 0 minus 2 is negative 2. If it's x minus 4, add 4. So we get negative 2 and 4. And those are my excluded values. X cannot equal negative 2 or 4. Probably when you type these into Math Excel, you can probably just separate them with a comma, would be my guess. That's usually what they have you do. Okay, so when you go to do your excluded values, if you have multiple factors, just set each factor equal to 0. That's the easiest part there. Okay, you ready for the bottom half of this page?
Okay.
A squared minus 3a plus 2 over 3a minus 3.
The top factor.
Yeah, the 3a.
Do the parentheses.
Okay, so the top factors into the parenthesis thing. So we just gotta have to talk the right lingo here to understand what she's saying.
It's the official name.
Well, you know what? If you do kind of know what you're doing, it makes it. We know what you mean. You know. Not the official lingo, but we know what you mean. So, okay, parenthesis thing. A squared breaks into a times a. And what do we need our numbers to do?
Positive and negative.
Add to. No. Product of 2.
Okay, so they're going to product of 2, or in other words, they're going to multiply to be 2. Well, before we go any further, what is the only set of numbers that multiply to be 2?
1 and 2.
1 and 2, yes? So what numbers must we use here?
1 and 2.
1 and 2. We just have to consider signs now. What do we need these numbers to add up to be?
-3.
Yeah, -3. So how do you multiply to be a positive? In order to multiply to be a positive, my signs are either both positive or both negative. If it adds to be a negative, we know both signs are going to have to be negative. And your calculator could help you double check that, couldn't it? You know, if you forget what you're doing with your signs. Okay, so that's our numerator. What about the denominator? How do we factor 3a minus 3?
3 minus 3.
What should be our first question when we're factoring? Is there a GCF?
GCF.
Is there a GCF?
No.
Well, no.
Well, okay, 3.
3a and 3 don't have anything in common.
Okay, 3.
I'm glad you can see it my way. Okay, so they both have a 3 there, yes?
Yeah.
So if we have 3a and we divide by 3, what remains?
1.
Just a, right? Or in other words, 1a, right? So if we take this 3 and you divide by 3. What about if you divide this 3 by 3? Yeah, -1. Okay, so in the numerator, I have factors of a minus 1 and a minus 2. In the denominator, I have factors of 3 and a minus 1. Any common factors here?
A minus 1 and a minus 1.
Ah, we're catching on now? Factor of a minus 1 cancels with a factor of a minus 1. Anything else you want to cancel? Okay. So what remains as my answer then?
A was A minus 2.
Okay, I can do that. It's kind of interesting because in Algebra 2, we're not doing rational expressions. We don't do that until second semester. But we are factoring. So
I noticed that. I noticed the Claire's doing like
okay. Am I done? No. Okay. How do we find excluded values?
Get your denominator.
And put it equal to
0.
0. Denominator equal to 0. So 3a minus 3 equals 0.
Add 3.
It's 3a minus 3. We do want to add 3. 0 plus 3 is 3. Okay, it's 3a. How do we get a by itself? It's 3 times a. We're going to divide by 3. 3a divided by 3 is a. What's 3 divided by 3? 1. So what do we know?
A does not equal.
A cannot equal 1. In other words, if I put 1 into this problem, it'd give me a denominator of 0.
The fly like landed on my face. Sorry, it freaked me out.
The flies are a little crazy in here today.
Usually they're more skittish.
Yeah, no, they're not. I think because I think they're on their last legs. They got locked in here all weekend, and you know, well, no food source over the weekend, and so I don't know because they seem rather crazy today, and they're definitely not skittish. Okay, next example.
Okay. Do the factor, whatever. What is it called?
I call it product and sum.
Okay.
I don't know. Is there very well could be a better name for it than that, but I just call it product and sum.
Okay. Do that.
Okay. So on top, she says we're going to do product and sum. So since it's just c squared, that means I'm going to do
See.
2 parentheses. C squared becomes c times c. What about numbers? They need to multiply to give me what?
-6.
Yeah, they need to multiply to give me -6, and they need to add to give me
-1.
-1. Well, it's going to have to be some combination of
1 and 6.
I'm going to have to disagree there.
Wait, okay.
1 and 6 cannot add or subtract to give me 1. Because 1 and 6 either add to be 7 or subtract to be 5.
Oh, okay.
So what else multiplies to be 6?
3 times
2.
Okay, let's try 2 and 3. I like those better. If we're going to multiply to be a negative, we need positive and negative.
3.
If it adds to be -1, larger value negative. Okay. Denominator.
Same thing. Parentheses.
Same thing again. Just different values. So this time we're going to do a product of 6, but a sum of 5.
Now it's 1 and 6.
Okay. If we multiply to be positive,
Oh, no.
what kind of signs do we need?
Positive and positive are negative and negative.
Positive and positive or negative and negative. Since we add to be a positive, we need these signs to be positive and positive. So we know it's going to be C plus and C plus. So we are going to actually have to use 2 and 3, aren't we? You guys are killing me here. You guys are full of the yawns. I'm full of the yawns.
I'm real tired by this time.
And especially on a Monday. I get it. Okay. What do you notice?
They're both, well, here there's the C plus 2.
C plus 2 cancels. What remains as my answer?
C minus 3 over C plus 3.
C minus 3 over C plus 3. Notice they have different signs, right? A minus and a plus. So I'm not canceling those C's and 3's because you have to be able to cancel the whole factor. And excluded values. How do you want to find excluded values on this one?
Use the already factored thing.
Use the already factored thing. I definitely agree there. So I'm going to set C plus 2 times C plus 3 equals 0. And I don't know, you guys might have even already skipped and already separated them out. Okay. So set each part equal to 0. C plus 2 equals 0. C plus 3 equals 0. If it's C plus 2, I'm subtracting 2. If it's C minus 3, I'm subtracting 3. We get C equals -2 and C equals -3, which really means C does not equal -2 or -3. Okay, this factoring's all coming back to us, right?
Yes.
And here's the deal. Let's see. Kylie, you're in first semester algebra. But Jacob, you're not, are you, right now? So you would not have seen it this year. it's got to be in first semester algebra. So you factored already this year with Mrs. Rogers. Unless I taught you factoring already this semester, but I don't think I did. I think it had to have been in first semester. Unless you haven't gotten to it yet and it comes up yet. I don't know. I need to look in the first half of the algebra book. I'm not as familiar with my algebra 1 book because I haven't taught out of it in years. So okay. Next one. I thought about skipping this one, but it's actually a really good one to look at. So what are some observations about this next one that says 2x minus 5 over 5 minus 2x?
It's just the same thing flipped.
Okay, same thing flipped. So here's my recommendation. We are used to having the letters first, correct? Not exactly. We're used to having the x's first. So my recommendation, so we can see what the relationship here is, the top I'm fine with. 2x minus 5 is good. But the bottom, if we flip those pieces, and I put the 2x first and the 5 second, what kind of 2x is this in the denominator?
Negative.
It's a minus 2x, so negative. What kind of 5 is this?
Positive.
A positive. Okay, so now we can see a little bit more. They were flipped, right? What do you notice about the signs? Positive here, negative here, positive here. So let's take on bottom and factor out a GCF of, no. What can we factor out here? What's that first term? It is a negative. So let's factor out a negative 1 on bottom. I have a reason, I promise. And I guess, I should have asked this differently. Okay, what can I factor out on top?
I don't know.
I don't think you can.
And if all else fails, what's always in common?
The 2. A 1.
A 1. So officially, if I factor a 1 out on top, okay, if I factor out a 1 on top as a GCF, well, what happens in the parentheses? 2x divided by 1 is still 2x. Minus 5 divided by 1 is still minus 5. Now, the whole reasoning then is now in the denominator, if we factor out a negative 1 instead, what's 2x divided by negative 1?
Negative.
Now, if I take negative 2 and I divide by negative 1, it's positive 2x. What if I take positive 5 and divide by negative 1? It's going to be negative 5.
Cancel each other out.
Do you see what I was trying to do here?
Yeah.
I have a 2x minus 5 on top and a 2x minus 5 on bottom. What remains then? 1 over negative 1, which, what is 1 divided by negative 1? Negative 1. Okay. And of course, as always,
Excluded values.
excluded values. Whether you remember what to call them or not, right?
Yeah. Struggling.
And how am I going to find this excluded value?
Denominator.
Okay. What denominator are you guys setting equal to 0?
The original.
I mean, we have options here. We can do 5 minus 2x, or we can do negative 2x plus 5.
2x
Either or.
plus 5.
The negative 2x plus 5? Okay. If I do negative 2x plus 5, how do I solve? Okay, so if it's negative 2x plus 5, we shall subtract 5. Negative 2x equals
Negative 5.
negative 5. If it's negative 2 times x, we're going to divide by negative 2. Negative divided by a negative is a
Positive.
Positive. 5 divided by 2?
It just
I'm going to say 5 divided by 2. It's 5 halves. Math Excel might let you put 2.5, 2.5. But they also might make you leave it as this and say x cannot be 5 halves.
yeah.
I think your fly's over on my desk now. Oh, it just flew off.
I'm gonna get bothered, yeah.
Okay, one last one.
Do the parentheses or the sum.
On top,
Yeah.
I wouldn't necessarily call it product sum, but we are going to do parentheses.
Something, but you
Now.
still have the y squared.
I'm trying to decide how I want to do this. Okay, so on top, y squared minus 16. What you have to get in the habit of noticing, y squared is what I would call a perfect square. I can take the square root of it. 16 is a perfect square. I can take the square root of it, right? And there's a subtraction sign in the middle. So this is the difference of squares, and it can be factored into 2 parentheses. What do we know y squared breaks into?
Y and y.
Y and y. It also so happens that the square root of y squared is y. What's the square root of 16?
4.
4. So on the back of each parenthesis, I'm going to put 4 and 4. How do you multiply to get a negative 16?
One's positive, one's negative.
One's positive, one's negative. So that's how we factor the top, difference of squares. Denominator.
You can't really do anything.
Teacher, slight interruption. At this time, any junior or senior who ordered pies, please report to the library.
I'm really glad you guys aren't juniors or seniors, because I'd be frustrated that I had no warning on that.
Okay.
Okay,
4 minus y, you can like flip that k so it's y plus 4, and then you can cancel it out.
not exactly, but okay, you're partway there. Let's go with the whole flip it option.
Okay.
So if we flip the order of this, if I put y and then 4, what kind of y is it?
Negative.
Negative y. What kind of 4 is it?
Positive.
Positive 4. Now, this doesn't exactly match either parenthesis. But do you remember what happened on the previous problem when we had a negative out front? We did a GCF of
Negative 1.
negative 1. So I'm going to suggest you do the same thing here. So just carry over your numerator again. Y plus 4 and y minus 4. We'll deal with that in a moment. In the denominator, if you factor out a GCF of negative 1, what is negative y divided by negative 1?
Y.
Yeah, negative divided by negative is a positive. What is 4 divided by negative 1?
Negative.
Negative 4.
And that's our well, no, because the y and negative 4 can cancel each other out.
Y minus, yeah, the whole reasoning, we made it there finally, yes? The y minus 4 matches exactly with the y minus 4. So, let's see, what remains? On top,
Y plus 4.
y plus 4.
No,
On bottom,
negative.
negative 1. If I had to guess, Math Excel would not let you leave it like this. They'd make you go one last step. Because this is just a negative 1, both terms can divide by negative 1. So if I divide both terms by negative 1, y divided by negative 1 becomes
Negative 1.
negative y. And plus 4 divided by negative 1 becomes minus 4. So my guess is they would make you do that. Again, I could be wrong. But my guess is they would make you simplify it that way. She just, something delighted her here. Okay. And we need to talk about excluded values. How do I find excluded values? Denominator equal to 0. So I'm going to say negative y plus 4 equal to 0. If it's negative y plus 4, I'm going to subtract 4. Negative y equals negative 4. If it's negative y, how do I get rid of that negative? Divide by a negative 1. And a negative divided by a negative is a positive. Negative 4 divided by negative 1 is positive 4. So y cannot equal 4. Okay. I don't know if you've started this homework or not. I haven't looked.
I did not.
But
I think I did like 1 or 2 problems.
it's lesson 11.1, and it should be available in Math Excel.
Yeah, this one was not flipped.
So exciting. You don't have them.
Oh, that's true.